Welcome to DevOps Fundamentals for Beginners 2023. If you are new to the world of DevOps, you are in the right place. In this video session, we will break down DevOps concepts and practices into simpler terms. You will learn how DevOps makes software development faster, more reliable, and more collaborative. We'll start from basics and gradually build your understanding. Whether you're a developer, IT professionals, or just curious about DevOps, join us on this journey to uncover the fundamental principles that drive modern software development.
We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products, and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another point here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to Agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages, and there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to Waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
If you're into the tech industry or just curious about the role of DevOps in software development, you have come to the right place. So what exactly is DevOps? In simple terms, it's a set of practices and tools that help developers and operational team work better together, releasing software faster with higher quality. At its core, DevOps is about breaking down barriers between development and operations and creating a culture of collaboration that focuses on delivering value to customers as quickly and efficiently as possible. Of course, this is a vast oversimplification, and there are many different aspects to DevOps that we could spend hours diving into. But for now, let's focus on some of the key responsibilities of a DevOps engineer, who is the person responsible for implementing and overseeing DevOps practices and processes.
But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to Simplilearn to stay updated with all the latest technologies. And hit that bell icon to never miss an update from us. To streamline the entire software development lifecycle by integrating and optimizing processes, tools, and methodologies. It encourages a culture of shared responsibility where developers and operations team work together closely throughout the entire software development lifecycle, from planning and coding to testing, deployment, and monitoring. Now the question is, who is a DevOps engineer? Well, you got it right. A DevOps engineer is a professional who combines software development expertise with operations knowledge to facilitate collaboration, streamline processes, and improve software delivery and infrastructure management within an organization. A DevOps engineer role is to bridge the gap between development and operations team, enabling efficient and reliable software development and deployment practices. But the question is how to become a DevOps engineer. What are the skills that you need to possess to become a good DevOps engineer? Well, a DevOps engineer possesses a wide range of skills, including proficiency in scripting and programming languages, knowledge of various tools and technologies, expertise in system administration, cloud platforms, and containerization technologies, as well as strong problem solving and communication skills are necessary. Firstly, having a good coding knowledge. Well, tools like Confluence, Jira, Git, these tools can support and enhance collaboration and project management within a DevOps environment. Next, having a good knowledge on deployment tools are also necessary. Now, tools like DCOS provides orchestration capabilities for distributed applications, Docker enables containerization for consistent and scalable deployments, and AWS offers a broad range of cloud services for infrastructure provisioning, scalability, and managed services. Next, you need to have a good knowledge on operations tools as well. Now, Chef and Ansible focus on infrastructure automation and configuration management, while Kubernetes specializes in container orchestration and management. These tools are utilized in DevOps to automate various aspects of software development life cycles, including infrastructure provisioning, configuration, management, application deployment, and scaling. Moving ahead, you need to have a strong grip on monitoring tools. Nagios, Splunk, and Datadog are three commonly used tools in the field of monitoring and observability. Now, each tool serves a specific purpose in monitoring and managing system and applications. Nagios specializes in infrastructure and application monitoring. Splunk focuses on log analysis and data visualization. Datadog provides comprehensive monitoring and analytic capabilities in cloud environments. These tools play a crucial role in maintaining the health and performance of systems and applications. Moving ahead, you need to have a good knowledge on Jenkins and CodeShip. Now, Jenkins and CodeShips are both essential tools in DevOps practices. Jenkins is a flexible and extensible automation server that supports continuous integration, testing, and deployment. On the other hand, CodeShip is a cloud-based CI/CD platform that offers simplicity and ease of use, particularly for cloud-native applications. Both these tools contribute to improving development productivity and code quality. And finally, having a good knowledge on testing tools like Selenium, JUnit are necessary for a DevOps engineer. JUnit is primarily focused on unit testing and automated testing of Java code, while Selenium is geared towards functional testing and automation of web applications. Both these tools play critical roles in DevOps workflow, contributing to faster feedback cycles, improved code quality, and reliable software releases. So these are some of the main and important skills that you need to possess as a DevOps engineer. Before moving ahead, let's take a minute and listen to the experiences of our learners who have enrolled in the DevOps PGP program, which has proven to be highly beneficial earlier. So here are some of the top 5 roles and responsibilities of a DevOps engineer in detail. First on the list, we have collaboration and communication. Now, DevOps engineers facilitate effective communication and collaboration with development and operations team. They actively participate in meetings and discussions to align goals and expectations. Now, as a DevOps engineer, you need to engage in regular meetings and discussions. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Actively listen and understand the requirement, concerns, and feedback. Now, when engaging with development and operations team, DevOps engineers practice active listening. They pay close attention to the requirements, concerns, and feedback expressed by team members from both the sides. By understanding their perspectives, pain points, and suggestions, DevOps engineers can better assess the needs of their teams and collaborate to find suitable solutions. Facilitate effective communication channels. Now, DevOps engineers take the initiative to establish and maintain effective communication within the organization. This often involves setting up dedicated chat platforms like Slack, Microsoft Teams, or collaboration tools like Jira to foster better collaboration and ensure that information flows smoothly between the teams. And finally, encourage cross-functional collaboration. Now, DevOps engineers recognize the value of cross-functional collaboration and knowledge sharing among the team members. They actively encourage them from development and operations team to collaborate, exchange ideas, and share their expertise. Second on the list, we have infrastructure automation and configuration management. Now, DevOps engineers focus on automating infrastructure provisioning and managing configurations using certain tools. They define infrastructure as code, enabling efficient deployment and scaling of resources. Now, as a DevOps engineer, you have to identify the infrastructure requirements effectively. Now, DevOps engineers work closely with development teams to understand the infrastructure requirements of the application. This involves analyzing the needs of applications in terms of computer resources, storage, security, networking, and scalability. By gathering all these requirements, DevOps engineer can ensure that infrastructure is provisioned and configured to meet the application-specific need and future growth. Write infrastructure automation scripts and templates. Now, once the infrastructure requirements are identified, DevOps engineers use automation tools and techniques to define the desired state of infrastructure components. They write scripts and templates that specify how the infrastructure should be provisioned, configured, and managed. Automate the provisioning, configuration, and management of servers. Well, DevOps engineers leverage infrastructure as code, or in short IAC principles, to automate the provisioning, configuration, and management of servers, networks, and other infrastructure resources. They use tools like Ansible, Chef, or Puppet to automate the deployment and configuration of infrastructure components. And finally, regularly update infrastructure code. Now, DevOps engineer uses version control systems like Git to track changes, collaborate with team members, and manage different versions of infrastructure code. By regularly updating and versioning infrastructure code, DevOps engineers can easily track and revert changes whenever necessary. Now, third on the list, we have continuous integration and continuous deployment, or CI/CD in short. Now, DevOps engineers are responsible for establishing and maintaining CI/CD pipelines, which enable developers to integrate code changes seamlessly and deploy applications rapidly. So for that, they have to set up a version control system. Now, version control systems like Git play a crucial role in DevOps by providing a centralized repository for managing code and tracking changes. Setting up a version control system involves creating a repository, initializing it with the code, and defining branching and merging strategies. Configure a build server. Now, a build server automates the process of compiling, testing, and packaging application code. Tools like Jenkins and GitLab CI/CD allows you to define build pipelines that specify the steps to be executed. These pipelines typically involve tasks such as pulling code from repository, compiling source code, generating artifacts, and packaging the application. Next, automate the deployment process. Now, automation of the deployment process is crucial for achieving rapid and consistent software releases. Containerization tools like Docker provide a lightweight and portable way to package application and their dependencies. Docker containers can be created and deployed consistently across different environments, ensuring consistency between development, testing, and production. Define and enforce quality gates and monitor CI/CD KPIs. Quality gates ensure that the code meets predefined quality standards before it is promoted to the next stage of the CI/CD pipeline. Automated testing, including unit test, integrated test, and end-to-end test. Integration test and end-to-end test help catch bugs and validate the functionality of the managing applications. And finally, measuring KPIs of the CI/CD pipeline provide insights into its performance and help identify areas for improvement. Well, next we have monitoring and performance optimization. Now, DevOps engineers monitor system performance, identify and optimize the infrastructure and application stacks whenever necessary. They implement monitoring tools to collect and analyze metrics, logs, and traces. So for that, select and configure monitoring tools. Now, monitoring tools like Prometheus or Grafana can be used to collect and visualize these metrics, allowing teams to identify bottlenecks or optimize processes and enhance the overall efficiency of the CI/CD pipeline. Also, they have to collaborate with the development and operations team to fine-tune application performance. So, continuously optimizing the infrastructure, which will ensure high availability, scalability, and reliability of that application. And finally, we have security and compliance. Now, DevOps engineers play a critical role in implementing security measures and ensuring compliance with industry standards and regulations. They work closely with security teams to define and implement security controls throughout the software delivery pipeline. So they have to continuously collaborate with the security teams to identify and define security requirements and controls, and implement security measures such as vulnerability scanning, access management, and secure configuration. They have to continuously integrate security testing and code analysis into the CI/CD pipeline and monitor for any sort of potential security risks or breaches and respond promptly to mitigate any identified vulnerabilities. So these were some of the main or top 5 roles and responsibilities of a DevOps engineer.
Talking about the salary figures of a senior DevOps engineer, according to Glassdoor, a senior DevOps engineer working in the United States earns a whopping salary of $178,362. The same senior DevOps engineer in India earns 18 lakh rupees annually. To sum it up, as you progress from entry level to mid level and eventually to experienced DevOps engineer, your roles and responsibilities evolve significantly. Each level presents unique challenges and opportunities for growth, all contributing to your journey as a successful DevOps professional. So excited about the opportunities DevOps offers? Great. Now let's talk about the skills you will need to become a successful DevOps engineer. Coding and scripting. Strong knowledge of programming languages like Python, Ruby, or JavaScript and scripting skills are essential for automation and tool development. System administration. Familiarity with Linux, Unix, and Windows systems, including configuration and troubleshooting. Cloud computing. Proficiency in cloud platforms like AWS, Azure, or Google Cloud to deploy and manage applications in the cloud. Containerization and orchestration. Understanding container technologies like Docker and container orchestration tools like Kubernetes is a must. Continuous integration or deployment. Experience with CI/CD tools such as Jenkins, GitLab CI or Circle CI to automate the development workflow. Infrastructure as code. Knowledge of IAC tools like Terraform or Ansible to manage infrastructure programmatically. Monitoring and logging. Familiarity with monitoring tools like Prometheus, Grafana and logging solutions like ELK Stack. Acquiring these skills will not only make you a valuable DevOps engineer, but will also open doors to exciting job opportunities. So to enroll in the postgraduate program in DevOps today, click the link mentioned in the description box below. Don't miss this fantastic opportunity to invest in your future. So let's take a minute to hear it out from our learners who have experienced massive success in their career through a postgraduate program in DevOps.
Hello everyone and welcome to Simplilearn's YouTube channel. You might already know from the title and thumbnail of the video that today we will discuss the difference between Agile and DevOps. But before that, let's take a step back and understand what these two are and why it's important to know these two methodologies and their differences. A software development methodology is like a set of instructions or guidelines that tell the team and individual involved in the software development how to build software. Just like a set of instructions helps the team make sure they do everything right, a software development methodology provides a roadmap for building software products. It outlines the steps involved in the software development process from planning and designing to testing and deployment. A software development methodology is like a set of best practices that help teams build high-quality software products in a timely and efficient manner. And Agile and DevOps are two of the many software development methodologies. Hope this quick introduction helped you understand why we need to understand the software development methodologies and their differences. So let's quickly start with our topic, Agile versus DevOps.
On that note, if you aspire to advance your career in the DevOps field and secure position in the top tier companies, consider enrolling in the postgraduate program in DevOps, an intensive training course that equips you with the top tools and skills developed in collaboration with Caltech CTME. This professional development program ensures your expertise aligns with industry standards. Our innovative blended learning approach combines live online DevOps certification classes with interactive labs, providing valuable hands-on experience. Also, accelerate your career growth with the highly regarded Certified Scrum Master certification. Gain the necessary knowledge and skills to excel in Agile project management through Simplilearn's comprehensive 2-day CSM training course. Led by experienced instructors, this course covers all essential Scrum frameworks concepts, preparing you thoroughly for the CSM certification. Now let's begin with the topic of Agile versus DevOps. Agile and DevOps are two distinct approaches in software development, each with its focus and objectives. Here's a detailed comparison between Agile and DevOps. First, methodology. Agile software development methodology emphasizes flexibility, adaptability, and iterative development, whereas DevOps is a cultural and operational philosophy emphasizing collaboration and integration between development and operation teams. Next, we have objectives. Agile aims to deliver high-quality software through incremental development, collaboration, and continuous feedback, whereas DevOps aims to streamline software development and deployment process, enhance collaboration, and achieve faster time to market. Next, let us see the focus of Agile and DevOps. Agile focuses on effective project management, closer customer collaboration, and delivering working software in short iteration. DevOps focuses on automating process, continuous integration and delivery, infrastructure as code, and improving communication and collaboration between teams. Next, let us look at the Agile and DevOps tools. First, the popular Agile tools widely used in the industry are Jira, Trello, Azure DevOps, version 1, and Monday.com. So these tools offers a range of features to support Agile practices, including backlog management, sprint planning, task tracking, collaboration, and reporting. The popular DevOps tools widely used in the industry include Jenkins, Docker, Git, Ansible, and Kubernetes. These tools are top-rated and widely adapted in various organizations to streamline development and operation process, improve efficiency, and enable faster and more reliable software delivery. Next, we have the key skill set practices. First, Agile methodologies. A solid understanding of Agile principles, frameworks, methodologies, and proficiency in Agile practices enable effective planning, iterative development, and continuous improvements. Next, iterative and incremental development. Agile professionals should be comfortable working in short iterations and delivering incremental value. And next we have adaptability and flexibility. Agile professionals should be open to change and adapt plans and prioritize as needed. Some standard Agile practices include Scrum, Kanban, and extreme programming. Some key skills and knowledge areas associated with DevOps are automation and scripting. So, proficiency in scripting languages like Bash, Python, or PowerShell is essential for automating routine tasks, infrastructure provisioning, and deployment process. Next, CI/CD pipelines, setting up and managing continuous integration and deployment pipelines. And then we have configuration management, managing and automating the configuration of systems and applications. And some more key skills and knowledge areas associated with DevOps are infrastructure as code, cloud platforms, monitoring and logging, and many more. And next, let's have a look at the benefits of Agile and DevOps. Agile enables faster response to change, improved customer satisfaction, and early and frequent delivery of working software. Whereas DevOps facilitates faster software delivery, improved quality through automating and testing, increased efficiency, and better alignment between development and operation teams. And next, let's have a look at some of the popular career opportunities in Agile and DevOps. So, in Agile, include the Scrum Master, Agile Coach, Product Owner, Agile Project Manager, and many more. And some popular career opportunities in DevOps include DevOps Engineer, Site Reliability Engineer, Automation Engineer, Cloud Engineer, and many more. Next, let's have a look at the salaries. The average salary for an Agile software engineer in the United States is around $175,000 annually. In India, it is 9 lakh per annum. The average salary for a DevOps engineer in the United States is around $104,000 annually. In India, it is 7 lakhs per annum. And some notable companies known for focusing on Agile and frequently hiring in this area are Spotify, Amazon, Google, IBM, Microsoft, and many more. Some companies are actively hiring and known for their prominency in DevOps include Cisco, Amazon, Google, Infosys, Microsoft, and many more.
But before we go on to see the differences between the two phases, let's first have a look at the basic definitions of the both. Henceforth, let's begin with what is continuous delivery. Continuous delivery is a software engineering practice in which code changes are prepared to be released to the production. It is to be kept in mind that the codes are to be passed through the automated unit testing, integration testing, and system testing before being pushed to production. The transition between the continuous integration phase and the continuous delivery phase is automatically completed, which includes automated testing at unit, integration, and system levels. Before continuing with continuous delivery, let me briefly explain what is continuous integration. Continuous integration, as the name suggests, is a DevOps practice that allows the developers to integrate their code changes or to merge their code changes in the central repository so that the automated builds and tests can be run. Let's come back to continuous delivery. The tests that happen in the integration phase provide validation that enables the developers to fix the bugs before the public release. The process of continuous delivery also enables the developer to release the software at any rate of their own choice. This means that the decision of initiating the release is made manually, and after that decision is made, continuous delivery takes place. Now moving on to the next topic, we shall see what is continuous deployment. Continuous deployment is a further step for continuous delivery, and this step is referred to be as the final stage in the pipeline. The phase or the step refers to the automatic releasing of any developer changes from the repository to the production. The ultimate goal is to release a newer version whenever the developer makes changes and automatically get those changes to the end users. In continuous deployment, codes are run in a simulated environment that ensures that the best quality factor is taken into consideration. There is also a feature of real-time tracking to keep a track of arising issues so that they could be resolved at the earliest. Now, when we know the definition of both continuous delivery and continuous deployment, let's see the contrast between the two. We have drawn the contrast between the two on the basis of three major factors. The three major factors are the definition of the two, advantages that they both have, and for whom or what kind of organizations use them. Let's begin with the first factor. The first factor we have is the definition. Continuous delivery is a DevOps practice that looks forward towards releasing the code changes to the production after all the testing has been performed. Whereas continuous deployment is a DevOps practice that focuses on continuously deploying or releasing the code changes into the production environment. Then the second factor is advantages. Here we will see the advantages of the two. Continuous delivery is known for frequent releases, while continuous deployment is known for completion of each deployment phase. Second advantage is continuous delivery is known to complete the releases in smaller segments, while continuous deployment is known for quick and more reliable completion. The next advantage in our list is continuous delivery is known for its instant response to defects and bugs, whereas continuous deployment focuses on automating the entire process. The final advantage of continuous delivery is that it is known for its comfortable, stable, and very reliable releases, whereas continuous deployment is popular for the creation of fully automated CI/CD pipeline. The third considerable factor is for whom. In this factor, we will see what kind of organizations or companies use these two practices. Continuous delivery is used by organizations that need to release new features on a frequent schedule. On the other hand, continuous deployment is mainly used by organizations that look forward to releases on a daily or hourly basis. The process of continuous deployment ensures cross-department coordination like development, support, marketing, business, etc. Now, when we know continuous integration, continuous delivery, and continuous deployment, it is important for us to understand how these three are related to each other. In the diagram on the screen, we can see the process of integration, delivery, and deployment in a simultaneous flow. We can see that first the build is initiated, which is then tested, and in the next step, it is merged. These three steps together make continuous integration. Then after these three steps comes the next phase, where the automatic release to the repository takes place, and this is called the continuous delivery phase. Lastly, the release reaches the phase where it is continuously released to the production, and this step is known as the continuous deployment phase. Now, to understand these better, we shall see each of these phases one by one to understand their relation with the CI/CD pipeline. The first phase in the CI/CD pipeline is the continuous integration phase. The process refers to the integration of all the code changes into a shared repository continuously. The process of continuous integration ensures that this code is tested and incorporated very smoothly. After the integration phase comes the continuous delivery phase. As the name implies, the phase looks forward to delivering the changes being made in the code after several iterations and feedbacks. In the continuous delivery phase, the team finalizes what is to be deployed to the customers and when. After the delivery phase comes the last phase, that is the continuous deployment phase. Continuous deployment phase is the phase that is completely free from human interference. There is a common goal that continuous delivery and continuous deployment share. That goal is to automate the entire development process. These phases are sometimes combined to each other to give the maximum productivity. So by now, I hope that you have understood the relevance and importance of all these three phases, and also how are these phases different yet related with respect to each other.
This topic by Simplilearn is going to explain you that what exactly is all about the continuous integration process, continuous deployment, and continuous delivery. So let's talk about these concepts one by one. So continuous integration is a kind of a process which comes up in the first part, right? So first the continuous integrations comes into the picture, then the continuous delivery and the deployment comes into the part. So the main important component or the main task which we primarily perform in the continuous integration is all about the build automations, test executions, and merging in various branches. So it's nothing but the integration of the source code from the each and individual developers' machines to a shared location, which we often call it as an kind of a version control system. So continuous integration is integrating the source code into the shared repositories, and then depending on the order triggers, once the changes are checked into the version control system, the automated build, test cases, all these executions can really happen. Now in the build process and the test cases automation, it's going to validate that how the source code is really working, how the compilation is going on, how the test cases are getting executed. So all these things are getting validated during the execution of these things. Now once the continuous integration is successful, we cannot give 100% surety that the code base is working fine, because it's just taking care of the compilation and the test cases. There could be a possibility that some kind of errors may also come up into the production environment because those test cases or those scenarios are not being covered in the test cases. So test cases are very important aspect over here, because it's giving us the authority whether we need to proceed further or we need to halt there itself. So after the continuous integration, the next process which comes into the picture is the automatic release to the repository over here, right? So it's just a kind of a mechanism where we will be releasing the source code to the artifacts. We are uploading the artifacts to the particular component. So that kind of automation is available. But that is also happening when we are saying that yes, the test cases execution is successful and we have to proceed further. And at the end, it's nothing but the automated deployment to the production environment, which we call it as a kind of continuous deployment over here. So these are the overall process which we are looking forward, so that we will be able to have an end-to-end automations going on over here with the help of CI/CD automations. Now continuous integrations, again, the build, test, merge, these are the different options which we do. So continuous integration is a kind of a process, a kind of a development process which is being used by most of the development teams nowadays, that eventually enables the developers to merge their source code, whatever the changes or whatever the modifications they are doing, they can like merge their source code from their local systems to the centralized repository, so that after that, with the help of CI tools, we can actually have the build automations and the test cases automation there. So this is the reason why we prefer the continuous integration process, because it depends on the basis of our modifications that how the whole build and test cases automations can really happen here. Now continuous integration is considered as a very important process because of the various reasons. Let's talk about those reasons one by one. The very first one is that it avoids the merge conflicts, because if we frequently sync back our source code from our systems to the shared repository, and the same thing can be done by other developers also, so eventually it definitely helps the different developers to collaborate their source code into a single shared repository, and that can really help you to avoid the merge conflict situations, because you are always going to work on the latest source code. So the scope of merge conflicts is not going to be there. It also helps us to decrease the need of the code review, because we are just doing the collaboration frequently, so we don't require any person to be sitting there and have to perform a kind of a heavy duty code review, because that is something which we can easily manage and we can work with that. So code review is something which we can easily decrease with the help of this continuous integration process. It also speeds up the development process. Yes, definitely, because the developers can easily collaborate with each other. So from collaboration perspective also, it's beneficial for us to do, and that can really help us to see that how easily we can integrate our source code, and that differs, or that basically helps us to go for the overall mechanism and going for a perfect automation process over here. So it also increases the overall development process which needs to be implemented during the CI process. Next, it also reduces the product backlog, because we are doing our changes frequently into the repositories. So any kind of product backlog which is there, which is pending from long, that is also can be managed easily, because it's keep on reduced there. So we keep on implementing our changes, we keep on implementing merging our particular changes to the shared repository, so that reduces the amount of backlog which is available. Now next thing is the continuous delivery, which is an automatic release to the repositories here. So what exactly is in continuous delivery all about? So continuous delivery is a kind of a practice that refers to the particular building, testing, delivering improvements to the software code. So the important part of continuous delivery is that the code is always in the deployable state. So we are saying that we are done with the delivery, we are ready with the delivery, and whichever environment, whichever particular server you want us to deploy, we are ready to do that. So that is where we call it as a continuous delivery. So we have our artifacts ready, and whenever is desired, whenever we feel that we want to do the deployments, we want to proceed further, we will be able to do that with the help of this process. So it's in kind of an end-to-end process. You do the builds, you do the test cases executions. Once the test case execution is done, once the testing is done, then you create an artifacts, you create a particular war files, jar files, ER files, whatever the artifacts we have, we prepare that artifacts, and then we deliver it to a specific environment. We say that yes, let's go with the delivery, let's make it into a particular state where we will be able to deploy to pretty much any environment which we feel as such over here. So that's the real beauty about the continuous delivery, where we can actually deliver it to whatever environment we feel we want to deliver. Now, continuous delivery is also something which is a very important concept for most of the organizations. So each and every organizations are actually looking forward to invest in this one for a variety of reasons, because it's something where we can invest some of our particular efforts, budget, money, a lot of things are there, but the kind of benefits which we get in the return, that's what we are going to talk about over here as such. So let's go with that. So it provides the higher quality of products. Yes, the efforts are there. Yes, the investment is also there. But in the return, the very important concept or very important thing which we get is the high quality of products here. So the kind of quality which we are getting with this one is quite high. And that's the biggest benefit which we get when we talk about any kind of continuous integration, continuous delivery, or continuous deployment here. So the quality is always top notch when we work off these particular processes. It also helps us to go for a quicker and less risky releases. So that's another benefit which we get this process. Customers are also satisfied because they feel that yes, we are going with this particular automated process. Within few days we are getting the deliveries. We don't have to wait for months for getting our deliveries. So that's the biggest benefit which a customer usually gets when he talks about the continuous delivery. And it's more efficiency is there, and the cost effectiveness of the team also. So from the cost and from the particular efficiency, all those parameters are fully fulfilled when we talk about the continuous delivery. So this process delivers a lot of benefits which can eventually help us to go for a perfect high quality product which we can develop as such over here. Now the next thing is the continuous deployment, which is an automatic deployment to the production environment. So let's see that what exactly is in continuous deployment all about here. So continuous deployment refers to the final stage in the pipeline. So which means that we are not only preparing our artifacts, we are not only doing the particular compilations or test case executions, we are actually going one step ahead. And this one step ahead is nothing but the deployment to the production environment. So this is what we are typically doing when we talk about the continuous deployment over here, that we are going to one step ahead, and that's where we are going for the deployment of our particular artifact. So we are deploying to the production environment so that our changes, whatever the changes we are trying to do, we are trying to make, that should be deployed to the production environment. Right now, so continuous deployment again can be deployed to higher whatever the organizations want to feel or want to deploy, they can actually go with that. And there are a lot of benefits actually which we get when we talk about the continuous deployment. So let's see about all these particular deployments one by one. So first of all, the faster development of the products is there. So we are looking forward that when we are going for the automations, when we are going for this deployment, so we get a kind of a faster development process which is there. So the products are getting developed very quickly, very fast. That's the biggest benefit which we are getting when we talk about this continuous deployment here. And it's less risky releases also there, and it's easy to fix problems. Whatever the automations we are feeling we are trying to perform, that can definitely help us to go that how we can automate and how we can go for these particular releases over here. So these releases are very less risky because we are doing all the things automated. There is not much of a scope which is there for the manual errors. So usually manual errors is something which is the biggest problem or which is the biggest risk when we go for any release, but that is something which is totally removed with this automation here. Now it also helps in continuous improvement in the quality, so continuously quality is also getting improved as such here. Now let's talk about that why exactly, as in we talk about at the industry level and the market level also, that the CI/CD is one of the best practices. Now what is the reason behind that? Why those are known as the best development and DevOps practices as such? Now continuous integration and continuous delivery are the best practices as they create an effective process. The kind of integration and delivering the source code, these are the prime things which we need to take care when we talk about the development teams over here. So they want an automated process first of all, and they also want a streamlined process which can take up the things which should not fail. It should be a fail-safe process mechanism through which they can release various kind of changes to the production environment, because ultimately they are looking forward for the deployment of the changes to the production environment. So how they are going to do that? That is where the CI/CD or the continuous integration and continuous delivery helps on that part, and that's the reason why they can help the teams, the development teams, to go for an effective process implementations when we go for these implementations of these two practices. Small code changes can be easily made in the software code, so you don't require much of the efforts. If you are going for even small changes in the source code, that can also be effectively deployed to a production environment. In a simple, straightforward and easy mechanism, the changes can go from the developer machines to the production environment. That's the biggest benefit which we get, due to which we feel that yes, these two processes should be implemented into a DevOps platform. Right, so CI and CD provides continuous feedback from the customers and also from the development teams, the DevOps teams. So the increase of transparency is also something which is important, which is implemented with these processes here. So the process enables faster release of the product, so we don't have to wait for months to release the source code there. Within couple of hours, within couple of days, we can actually release it to the production environment, provided we do all these steps like build, compilations, testing, development, validation. All these things will be done in that duration of time. So the failures can be easily detected faster, and we can easily find out that what is the problem with the code base, what is the problem with the changes, and we can even do the hot fixes. Now hot fixes, these kind of ad hoc changes are also can be easily deployed to the production environment within just a couple of hours there.
So if you are interested in taking your career to the next level, look no further than a postgraduate program in DevOps. This comprehensive course is designed to empower you with the skills and knowledge needed to excel in the dynamic world of DevOps. This program offers over 50 hours of self-paced learning, masterclasses led by Caltech CTME, 20 plus real-life projects in integrated labs, and the opportunity to acquire 40 plus in-demand skills and master 15 plus essential tools. Top it all with capstone projects spanning in 3 domains, and you will be well on your way to a successful DevOps career.
Learning objectives. By the end of this lesson, you will be able to describe the importance of continuous integration and continuous deployment, list the features of Jenkins and demonstrate their uses, list the features of TeamCity and demonstrate their uses, and select a suitable tool for your organization. The overview and importance of continuous integration and continuous deployment. Overview of continuous integration. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. These are develop and compile code, perform unit tests, integrate code with various types of databases, perform pre-production deployment activities, for example, moving code to various types of computing environments such as testing and staging, Also, part of a continuous integration process is to perform functional testing and apply labels against release points in the code repository. Additional activities in CI are to generate reports and analyze the code. Continuous integration is about combining code from each developer into a common deployment path automatically with a high degree of accuracy. Continuous integration is more than a developer just creating some code and committing it to a feature branch he or she is working on for automation to pick up and deploy. Instead, the developer needs to make sure that he or she writes unit tests that exercise each line of code written. The purpose of unit testing is to prove that the code that's written works to expectation. A standard feature of most shops that practice continuous integration is to have the process run all the unit tests in a developer's work branch before merging the code into a common code base. If the unit tests don't pass in the automated process, the developer's code is not merged into the common branch. Then, the developer is typically notified, either by email or by another communication channel, that there's a problem that needs to be corrected. Overview of continuous deployment. Continuous deployment is an extension of continuous integration. Its purpose is to reduce the time between a development team writing code and then using it in production. The benefits of continuous deployment are not only that it provides faster feedback from end users as each new feature is released to production, but it also realizes a faster return on investment for each feature as it gets developed. For the most part, continuous deployment is a highly automated process that reduces the need for human interaction in the deployment process. Scripts take over most of the work that used to be done by humans previously involved in the physical deployment of code. Not only does automation copy code from one computing environment to another, the scripts will actually create the computing environments that need to be in place before you can move the code along. Automation reduces the time it takes to get code from developer to end user and increases the accuracy of the code that's being produced. Continuous deployment makes sure that the right code is in the right place at the right time. Popular tools in continuous integration and continuous deployment. The more common CI/CD tools used in IT shops practicing DevOps are Jenkins, Travis CI, Bamboo, TeamCity, and GitLab. Continuous integration with Jenkins. Jenkins is one of the more popular tools in the DevOps landscape. It's a powerful framework that supports a broad plugin ecosystem. Instead of having to write code on a line-by-line basis to extend the power of Jenkins, developers write custom plugins to add new functionality. These plugins are highly reusable, so much so that a whole marketplace has evolved around the product. There are now over 1,000 plugins available, and most of these are free. Also, Jenkins integrates with over 100 other DevOps tools such as GitHub and testing tools from a variety of vendors. Jenkins allows DevOps personnel to reliably orchestrate the release tool chain, and it's designed to be an end-to-end solution. In order to get full benefit from using Jenkins, aspiring DevOps personnel need to understand the standard phases in the CI/CD pipeline. These phases are code and commit, build and configure, scan and test, release, and deploy. You're going to incorporate a variety of tools with Jenkins during each phase of the process. During code and commit, developers use an integrated development environment, also known as an IDE, to create code. The popular ones are Visual Studio, Visual Studio Code, and Eclipse. And then they'll check the code into a version control system such as Git, GitHub, Perforce, or Mercurial. Some code might require binary dependencies that are stored in an artifact repository, such as Artifactory. After code is created and committed, it needs to be built. If the code requires compilation into a binary file such as a DLL, exe, or jar file, Jenkins will use a build system such as MS Build, a C compiler, Maven for Java, or Ant for more general purposes. If the code needs to be containerized, you'll use Docker. Some IT shops will automatically create computing environments during build and configure in anticipation of impending code deployments. Tools such as Puppet, Chef, and Ansible can provision virtual machines automatically according to predefined configurations. During the scan and testing phase, you'll integrate Jenkins with testing tools such as JUnit, JMeter, Cucumber, or MS Test. Front-end testing can be conducted using Selenium, Appium, SauceLab, or Hewlett-Packard products. The purpose of scan and test is to make sure the code meets quality standards and is safe to move forward in the CI/CD process. The release phase is the last stage before code is released to users. You might integrate Jenkins with tools such as udeploy, Serena, Midvision, or XL Release. Finally, for deploy, you'll go on-premises to a cloud service or a hybrid combination of both a private on-premises cloud and a public cloud. For public cloud deployments, you'll target Amazon Web Services, Google Cloud, Azure, or IBM Cloud. Also, we're seeing cloud orchestration technologies such as Kubernetes take an increased presence as a release platform. For a private cloud, there's OpenStack. If you're working directly with virtual machines, you'll integrate Jenkins with VMware products or Docker. At a high level, in terms of application runtimes, you'll need something like the JBoss Java Virtual Machine or the WebSphere Application Server. Jenkins provides operational consistency in the various stages of release, regardless of the particular products you plan to use. Thus, you'll do well to keep these phases of deployment in mind as you continue on your journey to DevOps mastery. Continuous deployment with Jenkins. As you can see in the slide, continuous deployment, which we abbreviate as CD, consists of 5 operational stages. The first stage is coding, which is typically done on the developer's local workstation. The next stage is storage. During the storage phase, a developer commits his or her code to a source control management system such as Git, moving the code into a separate test computing environment, ensuring that the code is implemented in the best way possible, in addition to ensuring that the code works according to expectation so that it can be released to production, is done in the quality assurance and testing stages. Production is the final stage in the release process. Production is where the code is made available to end users. The value that Jenkins brings to the software development lifecycle is that it can be configured to automate every stage of the entire process. This is very important because it not only speeds up the software development process overall, but also increases the accuracy and reliability of the code under development. Companies such as LinkedIn, Google, and Facebook have made continuous deployment a fundamental part of the way they make software. It's only by using an automation tool such as Jenkins that effective continuous deployment is possible. Doing deployment manually is time-consuming and costly. Those who adhere to the principles of DevOps understand that continuous deployment is an essential part of the practice of software development in the modern enterprise, and automation is key to the practice. Continuous integration with TeamCity. TeamCity is a free continuous integration tool from JetBrains. The company is best known for its integrated development environments for writing software. The abbreviation for Integrated Development Environment is IDE. TeamCity is a complete continuous deployment, continuous integration system designed to automatically manage all aspects of the software development lifecycle. TeamCity is designed to integrate with all the popular products used in modern software development. It integrates well with the standard web browsers. As we've learned previously, communication among and between teams is important. Thus, TeamCity can be configured to send out notifications using email, RSS, chat tools, and social media platforms such as Slack. It supports version control by integrating with source control management systems such as Git, Subversion, Perforce, as well as many others. TeamCity supports all the build tools and development frameworks commonly found in the enterprise, such as Ant, Maven, MS Build, and Grunt. Also, TeamCity can be integrated with popular IDEs such as Eclipse, the various JetBrains tools such as IntelliJ, WebStorm, and PyCharm. TeamCity also integrates easily with the industry standard for developing Microsoft technologies, Visual Studio and Visual Studio Code. Continuous deployment with TeamCity. A good way to understand the workflow that TeamCity is designed to manage by way of automation is to conceptualize the software development process as having three areas of activity: artifact, deployment, and operations. Let's take a look at each area in detail. Artifact activity is about managing the various code components that make up a software system. Some shops use the term deployment unit to describe the distinct component of code that needs to be released into production. Other shops use the term deployment artifact. Some of these components might be a binary file such as Java or a jar file, or in .NET shops the artifacts can be an exe or a DLL file. Linux doesn't have the concept of file extension-based executables. Thus, any file can be an executable. You just need to have the right permission set. The important thing to understand about the artifact area is that it's about creating and managing deployment units that will be released to production. Deployment. Once an artifact or a collection of artifacts are ready for release, they need to go through a company's deployment process. There are a number of tools and processes associated with deployment activity. The ultimate goal of the deployment activity is to make sure that working, valuable software gets to the customer as quickly as possible. Typically, companies will use a ticketing system to control and monitor the work that needs to be done in deployment. Artifacts will be prepared for deployment. Computing instances will be provisioned. Sometimes the provisioning might involve creating virtual computing instances such as a virtual machine or a container. Other times it might require installing physical hardware such as computers and networking devices. Then, after provisioning is complete, the deployment artifacts are configured and pushed into relevant computing environments. And finally, we get to operations. It's important to understand that a comprehensive CI/CD system such as TeamCity goes beyond just deployment activity. TeamCity will also automate a lot of operations activity. Release personnel can use TeamCity features to orchestrate computing environments and monitor activity in those environments. Also, it coordinates important aspects of enterprise-level DevOps, such as logging and aggregating security alerts. Security is a critical aspect of any enterprise's operation and is of particular concern to any DevOps practitioner working within the enterprise. Overview and features of Jenkins. Jenkins as a continuous integration tool. Jenkins is a Java-based open-source automation tool. It functions as a server and is a software development and cross-platform tool used for continuous integration and continuous deployment. Let's look at what Jenkins can do. As a continuous integration server, it can be used as a CI server or a continuous delivery hub for a project. In terms of distribution, it can easily distribute work across different machines and help trigger builds, tests, and deployments to multiple machines and platforms quickly. Jenkins is designed to work cross-platform. It allows programming in software development environments such as iOS, .NET, Android, Ruby, and Java. Architecture of Jenkins. Jenkins is a comprehensive CI/CD framework that is designed to be flexible and extensible. It has a distinct object model that has classes like project and build. These classes describe the various components of the framework. It uses Jelly as the view technology. It uses the file system to store its data. Directories are created at the location on disk defined by the environmental variable Jenkins_home. It supports plugins which are plugged into those extension points and extend the capabilities of Jenkins. Popular features of Jenkins. Let's take a look at the features. 1. Jenkins is platform independent. 2. It has a rich plugin system. 3. It has the support of a large community of third-party developers and expert users. 4. It's designed to scale to meet the needs of the large enterprise. 5. Its automation capabilities enable immediate detection and resolution of issues. 6. It's open source and user-friendly. And 7. It's easy to configure, modify, and extend. Build status and job health. Every time a Jenkins job runs, the status of the build gets reported. The figure on the left side of the slide shows the results of a few runs of a build project. Notice that the result of each build is reported. Sometimes the build succeeds. Other times it fails. If an administrator aborts or disables the build, that gets reported too. The figure on the right side of the slide provides a description of the overall health of the project according to many builds. Assisted practice. Set up Jenkins. Let's take a look at the assisted practice. You are given a project to install and configure Jenkins on the Ubuntu operating system of your Learning Lab virtual machine. Lab 3.1. Installing and configuring Jenkins. In this demo, we're going to describe 3 steps to install and configure Jenkins. First, we're going to modify the file sources.list. Then we're going to use apt-get to install the Jenkins package. And then finally, we're going to run Jenkins in the browser. So let's get started. First, at the command line, we type make dir lab 3.1. Then, at the command line, we type cd lab 3.1 to navigate into the directory we've just created. Now, we need to add the key from the Jenkins package repository into our local environment. At the command line, we type wget -q -o https://package.jenkins.io/debian-stable/jenkins.io-key pipe sudo apt-key add dash, and this will add the key directly into the apt-get file system. Now we need to update the file sources.list. We'll use the Vi editor that's already installed in your classroom virtual machine. At the command line, we type sudo space vi space /etc/apt/sources.list. Sources.list is the file that apt-get uses to locate package repositories on the internet. We strike the I key on the keyboard to put Vi into insert mode. We scroll down to an empty space in Vi and type deb https://pkg.jenkins.io/debian-stable space binary /. Then we hit the escape key to get out of insert mode and type : W for write, Q to quit vi. Now we have to update the package manager. At the command line, we type sudo apt-get space update. Update executes. Once we see the line reading package lists ... done, the update is complete. Now we need to see if Java is installed, and if not, we need to install it. At the command line, we type java space -version. As you can see, Java and the Java Development Kit is already installed. If Java was not installed, you would type sudo space apt-get space install space openjdk-7-jre. This command will execute apt-get to install the OpenJDK package. Now we install Jenkins. Type sudo space apt-get space install space Jenkins. Strike the Y key to confirm installation. The installation process will take a few seconds. Now we're going to open the initial installation of Jenkins in a browser. We go back to the virtual machine desktop. In this case, we'll load the Firefox browser. We're going to enter the IP address of the Jenkins installation. The IP address was assigned to the virtual machine earlier. In the address bar of the Firefox browser, we enter the IP address 172.31.26.234:8080. 8080 is the port where the Jenkins server is running. Please be advised, the IP address of your virtual machine will be different, and the way you can discover the IP address is at the command line, type ifconfig. The IP address of your virtual machine will be in the information displayed. The first screen we're shown is the Unlock Jenkins screen. We're going to need to enter the administrator password in order to continue. As you can see in the red type, the location of the password is a file /var/lib/jenkins/secrets/initial admin password, where initial admin password is the name of the file that contains the password. We return to the terminal. We type clear to clear the screen. At the command line, we type sudo space cat space /var/lib/jenkins/secrets/initial admin password. We strike the enter key to display the password. We highlight the password in the terminal and then copy it by right-clicking on the mouse and selecting Copy. We return to the browser and paste the password into the administrator password text box. Then we click the Continue button. Firefox will offer to save the password, but we'll click Don't Save. We have the option to install suggested plugins, or we can select specific plugins to install. We're going to go with the Install Suggested Plugins method. We click the box labeled Install Suggested Plugins. The Getting Started page appears and the plugin installation continues. Once downloading and installing the plugins is complete, you'll be presented with the Create First Admin User page. At this point, we've successfully installed Jenkins. Now, the next steps will be to create the admin user by putting in a username, password, confirmation of password, a full name for the user, and the user's email address. Let's recap the important steps. Assisted practice, guidelines to install and configure Jenkins. Log into your Ubuntu Lab provided with the course. Open the terminal and execute the command available in the lab document 3.1 to add the key to the system. Edit the sources.list file and add the command to the file and then save it. Update the apt-get package. Install JDK 8+ version. Install Jenkins using apt-get package. Navigate to the IP address of the machine denoted as x.x.x.x:8080 in the browser of your virtual machine. Get the password and enter it into the Jenkins window. Create a new role job in Jenkins. Explore the Freestyle project and build section. Overview and the features of TeamCity. TeamCity as a continuous integration tool. TeamCity is a Java-based management and continuous integration server. It's licensed commercial software that's used for continuous integration and continuous deployment. TeamCity supports a number of features that are important to the continuous integration process. For example, gated commits ensure only working code is committed to deployment branches in source control. TeamCity supports integration with various integrated development environments, such as Eclipse and IntelliJ. It has a build grid that describes build activity. Also, it has cross-platform support for a variety of operating systems and programming languages. Also, TeamCity has seamless code integration. TeamCity Workflow. TeamCity supports the CI/CD process that has become the standard workflow for many companies and software development shops. Let's take a look at the overall workflow. As you can see in the slide at point 1, the first step is that a developer or tester checks code in to the source control management system. Upon commit at point 2, a build trigger message is sent to the TeamCity server. Then, at point 3, TeamCity works with system unit testing to start the system unit testing automation process. If the code passes the test, artifact building, archiving, and deployment tasks are performed in an automated manner at point 4. TeamCity reports the status of all the activities at point 5. Popular features of TeamCity. TeamCity has many features that make the CI/CD process more efficient. Let's take a look at the features. TeamCity has pre-tested commit, instant notifications, it has code coverage and monitoring capabilities, it provides a comprehensive build infrastructure, and it has enhanced version control system integration. TeamCity makes it easy to verify code, and it offers configurable test reports. And finally, TeamCity supports managing users and roles. Assisted practice. Set up TeamCity. Now it's time to do an assisted practice to set up TeamCity. You're going to be given a project to install and configure TeamCity on the Ubuntu operating system in your Learning Lab virtual machine. So let's get started with Lab 3.2, Install and Configure TeamCity. First, we create a directory for the work. We type mkdir lab 3.2. Then we navigate to that directory by typing cd space lab 3.2. First, we're going to download the compressed GZ file for TeamCity. Then we're going to extract the files from the compressed file. we're going to move the extracted directory that contains the files into another location. We're going to start up TeamCity. And then we're going to go to the browser and register a user with TeamCity. Let's download TeamCity. We go to the desktop of our Classroom virtual machine, and then we click on the icon for Google Chrome. Chrome appears. In the Chrome address bar, we type www.jetbrains.com/TeamCity/download. We click the download button. The GZ file downloads and the thank you page appears. We return to the terminal. At the command line, we type cd/home/Ubuntu/capital downloads/. We strike the enter key. This takes us to the directory where the GZ file has been downloaded. At the command line, we type ls to confirm that the GZ file is indeed in the directory. Notice the file teamcity-2018.2.1.tar.gz is listed. Now we need to extract the files. At the command line, we type tar space zxvf space teamcity-2018.2.1.tar.gz, and we hit the enter key. This will extract all the files into a directory named TeamCity. Now we need to move the directory TeamCity into the directory /opt/JetBrains. We create a directory by typing sudo space mkdir space /opt/JetBrains. Now we need to move the directory TeamCity into the directory /opt/JetBrains. At the command line, we type sudo space mv space teamcity space /opt/JetBrains/TeamCity. We strike the enter key. Now we need to give full read, write, and execute permissions to the files in the newly created directory TeamCity. At the command line, we type cd space /opt/JetBrains. We strike the enter key. Then we type chmod space -R777 TeamCity /. This says to give all rights to the directory and the contents of the directory TeamCity. We type ls just to make sure the directory TeamCity is indeed there. We type cd space TeamCity / and hit the enter key to enter the directory TeamCity. Then we type ls to take a look at the contents of the directory TeamCity. Notice there is a bin directory. We navigate into the bin directory by typing cd space bin and hit the enter key. Let's clear the screen to make things easier to see. To invoke TeamCity, we will execute the bash file /teamcity-server.sh/start. It's very important that you use the / characters. We hit the enter key and TeamCity starts up, spawning TeamCity and then TeamCity restarter running with PID 11618. And the PID, the process identifier, will vary according to systems. Now TeamCity is running. We go back to the browser, but before we do, take notice of the IP address of the virtual machine, which is shown on the command line on the left-hand side. The IP address of this virtual machine is 172.31.26.234. In the address bar of the Chrome browser, we type 172.31.26.234:8111, which is the port on the IP address where TeamCity is running. The TeamCity First Start web page appears. We click the Proceed button. The TeamCity is starting page appears. Then we see the database connection setup page. TeamCity allows you to choose from a variety of databases. We can use Postgres, MySQL, Oracle, or MS SQL Server. We're going to use the internal database. TeamCity creates the database and initializes its server components. This phase of the setup can take a few minutes. The page will reload automatically once TeamCity is through installing its server components. We're almost done with TeamCity's installation process. Then all we'll need to do is to create an account in TeamCity. When the installation process is complete, we'll be presented with the licensing agreement that we have to agree to. We scroll to the end of the terms and conditions. We click the checkbox for Accept License Agreement. We're going to uncheck Send Anonymous Usage Statistics. Then we'll click the Continue button. The web page Create Administrator Account appears. We enter the username Simplilearn. Then we add a password and confirm the password. Finally, we click the button Create Account. We'll also save the username and password information in Google Chrome. Upon successfully entering a username and password, we'll be presented with the My Settings and Tools webpage in TeamCity. The page allows us to access projects and changes and agents, as well as build queues. In the next demo, we'll look at more details. Let's recap the important steps. Guidelines to install and configure TeamCity. Number 1, log in to your Ubuntu lab provided with the course. Number 2, download TeamCity from the official site. 3, unzip the folder and install TeamCity. 4, provide the read, write, and execute mode access to TeamCity. Number 5, run TeamCity at x.x.x.x:8111, where x.x.x.x is the IP address of your local machine, or the machine where the server is running. 6. Create an account in TeamCity and add the basic details to complete the setup process. 7. Explore options such as projects, changes, agents, and build queue. Build tools and their uses. Build tools. Build tools are programs that automate the creation of applications from source code. Automation tools allow the build process to be more consistent. Some common build tools are Make, Bash, which ships with Linux, Ant, Apache Maven for Java, Grunt, and Gulp. Popular features of build tools. Well, we can start with compiling to binary code for languages such as C# and Java. Build tools will package a compiled program for deployment. Also, it will run automated test cases against the code. The build tool will deploy artifacts to production and will also generate documents for developers to use for later reference. And finally, a build tool will generate release notes. An overview of Apache Ant. Apache Ant is a Java library and command line tool. Its aim is to provide processes described in build files as targets and extension points dependent on each other. Let's take a look at some of the distinct features. Apache Ant supplies a number of built-in tasks that allow it to compile, test, and run code. It's flexible and does not impose coding conventions. It builds solutions by combining build tools and dependencies with Apache Ivy. It solves Make's portability problem. And users can develop custom Ant libs using Java. And finally, you can use Ant to pilot any type of process. The limitations of Apache Ant. In Apache Ant, there are a few limitations. Some of the limitations are: number 1, configuration error checking is limited. Undefined properties are not raised as errors, but are left as unexpanded references. Number 2, Ant has limited fault handling rules. Lazy property evaluation is not supported. Thus, you need to be very exact when configuring Ant. It is not a forgiving environment. Number 3, older tasks use default values, which are not consistent and can cause problems. You need to pay attention. Changing defaults can break existing Ant scripts. And finally, number 4, Ant build files are complex and verbose, as they are hierarchical and partly ordered. An overview of Maven. Apache Maven is a comprehensive software project management tool. Based on the project object model, also known as the POM, Maven can manage a project's build, reporting, and documentation from a central XML file. Let's take a look at the key points of Maven. Number 1 is backward compatibility and auto-parent versioning. The hierarchical structure of the POM XML file reduces the burden on version control and reconciliation of dependencies. Number 2, Maven supports model-based builds. Number 3, Maven supports parallel builds and better error integrity reporting. You can kick off a number of project builds that run asynchronously. Number 4, release management and distribution publication is built into Maven. The project object model is comprehensive and covers all aspects of the software development lifecycle, from development through testing and on to release. Number 5, instant access to the latest features with less or no additional configuration. Maven allows artifact version control that can be set to get the latest release of a dependency. Thus, you can make sure the code is always up to date. 6, large and growing repositories. There is a complete ecosystem of Maven artifact repositories that make it so you have access to popular components automatically. The Maven repository, found at https://mavenrepository.com, is a popular one. Also, a company can set up its own private repository. The drawbacks of Maven. Maven does have some drawbacks. Number one, unable to depend on outcome status. Maven builds can fail, leaving nothing behind other than error messages that can be very hard to understand. Number two, Maven is verbose and complex. It does take a while to master the details of the platform. Number three, slow and partial black box. Maven does a lot of things automatically, and sometimes these black box activities can be very opaque. And finally, number four, Maven can be unreliable when integrated for use within the Eclipse IDE. Comparing Maven over Ant. Well, Maven has better dependency management. It provides more powerful builds. There's better collaboration, and the debugging capabilities are a bit better than Ant. There's more componentization in the builds, and there's reduced duplication. And finally, the POM provides a more consistent project structure. The Project Object Model, also known as the POM. The Project Object Model is an XML representation of a Maven project. It provides general configuration information, such as a project's name, its owner, and its dependencies on other projects. The XML excerpt in the slide shows a rudimentary implementation of Maven's project object model. The POM XML needs to define the group ID, the artifact ID, and version. The packaging needs to be declared too. The default deployment package is a jar. The project described in the XML file in the slide has an artifact ID of calculator. You can think of the artifact ID as the name of the artifact that's going to be created. The POM shows a version of 1.0 and it belongs to the group with the identifier EU.TotalEclipse. You can think of the group ID as a way a company organizes a number of artifacts under a common name. Overview of Grunt. Grunt is a JavaScript-based task runner which is used to automate repetitive tasks in a workflow. It can be used as a command line tool for JavaScript objects. Let's take a look at some of the key points to understand about Grunt. In Grunt, developers write Grunt setup files to ease workflow. Thus, Grunt speeds up the development flow and enhances performance. It helps with the automation of repetitive tasks with less effort. It supports a small infrastructure which is a best fit for new code bases. Grunt minifies files such as HTML and CSS, thus reducing the potential problems with network latency. Grunt aims at reducing the chances of errors during repetitive tasks, and it includes built-in tasks to extend functionality of plugins. Currently, Grunt has over 4,000 plugins and can be used in large production sites. An overview of Gulp. Gulp is an open-source JavaScript toolkit used as a build system in front-end web development. It automates time-consuming and repetitive tasks involved in development. Some of the key features of Grunt are code minification and concatenation, usage of pure JavaScript code. Grunt converts files created under LESS or SAS in a CSS compilation process. LESS, which stands for Linear Style Sheets, is a dynamic preprocessor style sheet language that can be compiled into cascading style sheets, also known as CSS. And these style sheets are run on the client side or the server side. SAS is a preprocessor scripting language that is interpreted or compiled into cascading style sheets. Grunt also manages file manipulation in memory. Some of the advantages of Grunt are that it's easy to code, it's easy to test with web apps, and the plugins are simple to use. Some of the disadvantages of Grunt are there's more than the usual number of dependencies, multiple tasks cannot be performed in parallel, and configuration can become tedious. Assisted practice, continuous integration with Jenkins and Maven. You are given a project to configure in Jenkins. You need to make Jenkins pull get commits and build the project code using Maven on the Ubuntu operating system on your practice lab VM. Okay, so let's get started with Lab 3.3, continuous integration with Jenkins, Git, and Maven. In this lab, we're going to configure Jenkins to support Git and Maven. Then we're going to configure a Maven project. And then finally, we're going to build the Maven project using source code from Git. So in a web browser, we open Jenkins, and what we do in our Classroom virtual machine is we go to the IP address, and in this case it's 172.31.26.234:8080, and Jenkins typically runs by default installation. We click the new item link, which is on the upper left of the Jenkins web page. The new item web page appears. In the new project text box, we enter the project name, in this case, Java Maven. Then we select Freestyle Project, then scroll down the web page and click the OK button on the left-hand side. The web page for the newly created project loads. We add text to the description text box. This is a simple project to test Jenkins. We go to the menu bar at the top of the project's web page and we click the Build tab. We're taken to the Build section of the web page. We click the Add Build Step button to display a drop-down of options. From that drop-down list, we select the item Execute Shell. In the command text box, we enter the Linux command echo space quotation mark hello space from space Jenkins quotation. We click the Save button on the lower left. Now we'll do a test build to make sure everything's working all right. On the left-hand side of the project web page, we click the link Build Now. The build starts, and when it completes, you'll see a blue circular icon in the Build History section of the project web page on the left side. And you can see there's a build there, and it's labeled number 1. To the right of build number 1 is a drop-down arrow, which we click to get a list of options, and we select Console Output. Selecting Console Output will display in the web page the build log activity. Notice there's a line that says Hello Jenkins. This is from the echo command we entered in the Jenkins build configuration. Let's develop the project a little more. What we need to do is to add Git integration and get the project to work with Maven. We go to the Simplilearn site on GitHub, and that's Simplilearn DevOps Official. And we go to the repository Java Maven App. On the GitHub site, we click the green Clone or Download button to display the URL that we can use to access the Java Maven App repository on GitHub. So we highlight the URL and copy it. We go back to the Jenkins web page. In the Jenkins web page, on the menu bar, we click the tab for the Java Maven project. The Java Maven project appears. On the left side of the project's web page, we click the Configure hyperlink. This loads the project's configuration page, in which we click the Source Code Management tab. We're navigated to the Source Code Management section of the configuration page. There, we click the option Git. We paste the URL of our Simplilearn Java Maven app repository into the text box repository URL. Entering a valid URL will make the error message, "Please enter get repository," disappear. We're going to select some predefined credentials from the credentials dropdown. We added those earlier, but if you need to add credentials in the future, simply click the Add button and then select Jenkins. Now, if you're using your own GitHub repository, you'll be presented with the Jenkins Credentials Provider dialog. You're going to need to enter your username and also your password. Once we configure access to the Get repository, we click the Save button. Now, what we've done is we've effectively given Jenkins the right to access our GitHub account using our credentials. In other words, Jenkins is impersonating us. After we save the Get configuration, we'll be brought back to the Projects page. We need to go back to Jenkins Home. We click the Jenkins tab on the upper left of the project page. This takes us back to the main Jenkins dashboard page, which we can think of as Home. Now, we click Manage Jenkins on the left side of the Jenkins home page. On the Manage Jenkins page, we select Global Tool Configuration. The Global Tool Configuration page appears. We scroll down to the Maven section of the Global Tool Configuration page. We click on the button Add Maven to add a Maven configuration. We're going to give this installation a name, and we're going to call it Local Maven. Then Maven needs to know where its home is on the classroom virtual machine. In the text box labeled Maven_home, we enter the value /usr/share/Maven. An alternative method is to again click on Add Maven, add a name, this time Maven, and then from the Install from Apache dropdown, select the version of Maven that's on the machine. We've now let Jenkins know about Maven, so we can click the Save button. We return to the Manage Jenkins page. We need to return to the project. In the upper left-hand corner of the Manage Jenkins page, we click the Jenkins button. We're brought back to the Jenkins main dashboard. You can see Java Maven in the list of projects on the main dashboard. When we hover over Java Maven, we'll see a down arrow. We click that down arrow and some options appear. We select Configure from the Options dropdown. The Java Maven Projects configuration page appears. We click the Build tab in the menu bar. You can see the echo command that we created previously in the Build section. We want to get rid of it. So what we're going to do is we're going to go to the right side of the Execute Shell section and click the red button with the X label. Clicking the red button deletes the Execute Shell command, echo, from the Build section. Now we want to add a new build step. We click the Add Build Step button and we notice that another dropdown appears. From that dropdown we select Invoke Top-Level Maven Targets. After we add the Maven build task, we'll be presented with a Maven version dropdown. This will contain the Maven configurations we created previously. We select one of the configurations. In this case, we'll select Maven. Let's recap the important steps. Assisted practice, guidelines to configure Jenkins and Maven. Number 1, log in to Ubuntu Lab provided with the course. Number 2, log into Jenkins and create the first Jenkins job. Number 3, install and configure Maven. Number 4, configure Jenkins with Java, Git, and Maven. Number 5, create a Jenkins job for your Maven build project and run the project. Number 6, poll Git for commits and automatically trigger the build. Number 7, build a trigger using the push mechanism instead of pull. Number 8, repeat steps 6 and 7 multiple times to observe the results in the console output section.
So what are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run into is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public and shareable. It is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You will want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. later when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merged into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it could be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch, and we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's been done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config - global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A Git rebase will reapply commits on top of another base tip. And Git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the README file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into README file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for Git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world. And then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/simplylearn-github, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/simplylearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in, and we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature, and then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name, or by email address, or by their full name. One of the things that you want to be able to do is to ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2. And now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modify it. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text-free change that was made. And we can now go through a process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a. And we're going to commit those files. Git commit -a-m, adding 2 new files. And it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. And we can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files listed in correctly.
If we talk in the literal sense, Maven means accumulator of knowledge. Maven is a very powerful project management tool, or we can call it a build tool, that helps building, documenting, and managing a project. But before we move forward and dive deep into the basics of Maven, let's understand what is meant by the term build tool. A build tool takes care of everything for building a project. It generates a source code, generates documentation from a source code, it even compiles the source code and packages the compiled codes into jar of zip files. Along with that, the build tool also installs the packaged code in local repository, server repository, or central repository. Coming back to Maven, it is written in Java or C#, and it is based on Project Object Model or POM. Again, let's have a pause and understand what is meant by this term Project Object Model. A Project Object Model or POM is a building block in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build a project. This file resides in the base directory of the project as pom.xml file. The POM contains information about the project and various configuration details. It also includes the goals and plugins used by Maven in a project. Maven looks for the POM in the current directory while executing a task or a goal. It reads the POM, gets the needed configuration information, and then runs the goal. Coming back, Maven is used to building and managing any Java-based project. It simplifies the day-to-day work of Java developers and helps them in their projects. Now, when we know the basics of Maven, let's have a look at some reasons to know why is Maven so popular and why are we even talking about it. So, let's have a look at the need for Maven. Maven, as by now we know, is popularly used for Java-based projects. It helps in downloading libraries or jar files used in the project. To understand the part of why do we use Maven or the need of Maven, let's have a look at some problems that Maven solved. The first problem is getting the jar files. In a project, getting the right jar files is a difficult task, where there could be conflicts in the versions of the two separate packages. However, it makes sure all the jar files are present in its repositories and avoid any such conflicting scenarios. The next problem it sorted was downloading dependencies. We needed to visit the official website of different software, which could be a tedious task. Now, instead of visiting individual websites, we could visit mvnrepository.com, which is a central repository of the jar files. Then Maven plays a vital role in the creation of the right project structure in servlets, struts, etc. Otherwise, it won't be executed. Then Maven also helps to build and deploy the project so that it may work properly. So the next point is what exactly Maven does. It makes the building of the project easy. The task of downloading the dependencies and jar files that were to be done manually can now be done automatically. All the information that is required to build the project is readily available now. Finally, Maven helps manage all the processes such as building, documenting, releasing, and other methods that play an integral part in managing a project. Now, when we know everything about Maven, let's look at some companies that use Maven. There are over 2,000 companies that use Maven today. The companies that use Maven are mostly located in the United States and in the computer science industry. Maven is also used in industries other than computer science, like information technology and services, financial service, banking, hospital and care, and much more. Some of the biggest corporations that use Maven are as follows. First we have Via Varejo, then comes Accenture, followed by JP Morgan Chase & Company, then comes Craft Base, and finally we have Red Hat. With the first topic, that is the birth of Selenium. Selenium was primarily created by Jason Huggins in 2004. Jason, an engineer at ThoughtWorks, was working on a web application that needed to be tested frequently. He realized that the repeated manual testing of the application is becoming inefficient. So he created a JavaScript language that automatically controlled the browser's actions. This program was named JavaScript Test Runner. After he realized that his idea of automating the web applications has a lot of potential, he made the JavaScript Test Runner open source, and it was later renamed as Selenium Core. So we know that Jason was the person who initially created Selenium. But then we must also know that Selenium is a collection of different tools, and since there are different tools, there will be several developers too. To be exact about the number of different tools, there are 4 different tools that have their own creators. Let's have a look at all of them. The first tool is the Selenium Remote Control, or the Selenium RC, that was created by Paul Hammond. Then comes Selenium Grid, that was developed by Patrick Lightbody. The third tool is the Selenium IDE that was created by Shinya Kasatani, and the fourth tool, that is the Selenium WebDriver, was created by Simon Stewart. We shall be learning about all these tools in great detail as we move forth in our video. First, let's have a look at what is Selenium. Selenium is a very popular open source tool that is used for automating the tests carried on the web browsers. There may be various programming languages like Java, C#, Python, etc. that could be used to create Selenium test scripts. This testing that is done using Selenium tool is referred to as Selenium testing. We must understand that Selenium allows the testing of web applications only. We can neither test any computer software nor any mobile application using Selenium. Selenium is composed of several tools with each having its own specific role and serving its own testing needs. Moving forth, let's have a look at the features of Selenium, which will help us understand the reason behind its widespread popularity. So here we have a set of features of Selenium. Selenium is an open source and portable framework that has a playback and record feature. It is one of the best cloud-based testing platform and supports various OS and languages. It can be integrated with several testing frameworks and supports parallel test execution. We will be talking about all these features in detail as we move forward. So here, the first feature that we have is open source and portable framework. This feature states that Selenium is an open source and portable framework for testing web applications. In addition to that, Selenium commands are categorized in terms of different classes, which make it easier to understand and implement. The second feature is the playback and record feature. The feature states that the tests can be authorized without learning a test scripting language with the help of playback and record features. The next feature says that Selenium is a cloud-based testing platform. Selenium is a leading cloud-based testing platform that allows testers to record their actions and export them as a reusable script with a simple to understand and easy to use interface. Moving forth, the next feature states that Selenium supports various operating systems, browsers, and programming languages. The tool supports programming languages such as C#, Java, Python, PHP, Ruby, Perl, and JavaScript. If we talk about the operating systems, then Selenium supports operating systems like Android, iOS, Windows, Linux, Mac, and Solaris. And the tool also supports various browsers like Google Chrome, Mozilla Firefox, Internet Explorer, Edge, Opera, Safari, etc. Then the next feature we have is the integration with testing frameworks. Selenium can be well integrated with testing frameworks like TestNG for application testing and generating reports. And also, Selenium can be integrated with frameworks like Ant and Maven for source code compilation. The last feature in our list is the parallel test execution. Selenium enables parallel testing, which reduces time and increases the efficiency of the tests. Selenium requires fewer resources as compared to other automation testing tools. Now, let's move further and get to know different Selenium tools. By now we know that there are 4 different tools that come under the Selenium suite. The 4 tools are Selenium Remote Control, Selenium Grid, Selenium IDE, and Selenium WebDriver. We shall have a look at these 4 tools in detail one after the another. Beginning with Selenium Remote Control. Selenium Remote Control enables the writing of automated web applications in languages such as Java, C#, Perl, Python, and PHP to build complex tests such as reading and writing files, querying a database, and emailing the test results. Selenium RC was a sustainable project for a very long time before Selenium WebDriver came into existence, and hence Selenium RC is hardly in use today, as the WebDriver offers more powerful functionalities. The second tool we shall see is the Selenium Grid. Selenium Grid is a smart proxy server that enables the running of tests in parallel on several machines. This is made possible when the commands are routed to the remote web browser instances and one server acts as the hub. The hub here is responsible for conducting several tests on multiple machines. Selenium Grid makes cross-browser testing easy, as a single test can be carried on multiple machines and browsers altogether, making it easy to analyze and compare the results. Here, there are 2 main components of Selenium Grid, Hub and the node. Hub is a server that accepts the access request from the WebDriver client, routing the JSON test commands to the remote drivers on nodes. And here, the node refers to the remote device that consists of a native OS and a remote WebDriver. It receives the request from the hub in the form of a JSON test commands and executes them using the WebDriver. Moving forth, the third tool is the Selenium IDE. If you want to begin with the Selenium IDE, it needs no additional setup except installing the extension of your browser. It provides an easy-to-use tool that gives instant feedbacks. Selenium IDE records multiple locators for each element it interacts with. If one locator fails during the playback, the others will be tried until one is successful. The IDE makes the test debugging easier with features like setting breakpoints and pausing exceptions. Through the use of the run command, you can reuse one test case inside one another. And also, Selenium IDE can be extended through the use of plugins. They can introduce new commands to the IDE or integrate with a third-party service. The last and the fourth tool in the Selenium suite is the Selenium WebDriver. Selenium WebDriver is the most critical component of the Selenium tools suite that allows cross-browser compatibility testing. The WebDriver supports various operating systems like Windows, Mac, Linux, Unix, etc. It provides compatibility with a range of languages including Python, Java, and Perl. Along with it, it provides supports different browsers like Chrome, Firefox, Opera, Safari, and Internet Explorer. The Selenium WebDriver completes the execution of test scripts faster when compared to other tools, and also it provides compatibility with iPhone driver, HTML unit driver, and Android driver. Now, after you know about the tools, the question arises which tool to choose. So in the next topic, we shall see different factors on the basis of which we may decide which tool would be more suitable for us. Here, we shall have a look at the reasons why one should choose that particular tool. We shall begin with Selenium Remote Control. Selenium Remote Control or Selenium RC should be chosen to design a test using a more expressive language than Selenium. Selenium is a set of Selenium commands that are used to test our web applications. Then the Selenium RC might be chosen to run tests against different browsers on different operating systems. The RC may be chosen to deploy tests across multiple environments using Selenium Grid. It helps in testing the applications against a new browser that supports JavaScript and web applications with complex Ajax-based scenarios. Now, the second tool for which we shall see the reasons are Selenium Grid. Selenium Grid, as we learnt in the reasons for Selenium RC, is used to run Selenium RC scripts in multiple browsers and operating systems simultaneously. The grid is used to run a huge test suite that needs to be completed at the earliest possible time. Now comes the third tool. The third tool is Selenium IDE. Selenium IDE is used to learn about concepts on automated testing and Selenium. These concepts include Selenium commands such as type, open, click and wait, assert, verify, etc. The concepts also include locators such as ID, name, XPath, CSS selector, etc. Selenium IDE enables the execution of customized JavaScript code using run script and exporting test cases in several different formats. The IDE is used to create tests with a limited amount of knowledge in programming, and these test cases and test suites can be exported later to RC or WebDriver. Now finally, let's have a look at the reasons to choose a last tool, that is Selenium WebDriver. Selenium WebDriver uses a certain programming language in designing a test case. The WebDriver is used to test applications that are rich in Ajax-based functionalities, execute tests on HTML unit browser, and create customized test results.
So if you are interested in taking your career to the next level, look no further than a postgraduate program in DevOps. This comprehensive course is designed to empower you with the skills and knowledge needed to excel in the dynamic world of DevOps. This program offers over 50 hours of self-paced learning, masterclasses led by Caltech CTME, 20 plus real-life projects in integrated labs, and the opportunity to acquire 40 plus in-demand skills and master 15 plus essential tools. Top it all, with capstone project spanning in 3 domains, and you will be well on your way to a successful DevOps career.
So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same as the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and codebase, we use tools like Git and GitHub. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you'd do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker Hub where it can be shared across your entire team. And from the Docker Hub, users can get access to the Docker image and build their own new containers. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and the So we're able to get rid of the guest OS and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure, and you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system and he's coding away and he has to get that code over to a tester. Now what will happen is that tester will then typically in your traditional environment then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software but probably doesn't have all the development software, and certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of 2 key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say for instance you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just 2 commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password, so let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my So this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment. And we'll put in the image name, which is Ubuntu. And -bin -bash. And it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state. It's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container. it. We're going to break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the 2 different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively, and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software, one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed, and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable, directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation, and there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes, and it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you'd experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable and it is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network, so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining, or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. I'm going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about two key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself, and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15-20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually, you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pods, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network, and each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The scheduler, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer and increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
So if you are interested in taking your career to the next level, look no further than a postgraduate program in DevOps. This comprehensive course is designed to empower you with the skills and knowledge needed to excel in the dynamic world of DevOps. This program offers over 50 hours of self-paced learning, masterclasses led by Caltech CTME, 20 plus real-life projects in integrated labs, and the opportunity to acquire 40 plus in-demand skills and master 15 plus essential tools. Top it all with capstone projects spanning in 3 domains, and you will be well on your way to a successful DevOps career.
So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet, and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate authority to sign the actual document so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client, that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network, and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
The field of DevOps has grown exponentially over the past few years, and it's no surprise why. DevOps is a set of practices and tools that aims to break down the silos between development and operations team and streamline the software delivery process. By doing so, DevOps enables organizations to deliver high-quality software faster and more efficiently than ever before. So if you're interested in pursuing a career in DevOps, then this video on how to choose DevOps as a career is for you, with the proper roadmap on how to get started with it. Also, do not forget to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn. So without any further ado, let's get started. First is to understand the role of a DevOps professional. Before diving into the specifics of how to become a DevOps professional, it's essential to understand the roles and responsibilities of a DevOps professional. A DevOps professional is typically responsible for designing, implementing, and maintaining the infrastructure, automation tools, and processes required for the efficient delivery of software. This includes collaborating with development teams to integrate automation into the software development process, setting up and maintaining the infrastructure required for the software delivery pipeline, such as servers, databases, and network systems, developing and implementing automation scripts to improve the efficiency of software delivery process, continuously monitoring and analyzing the software delivery process to identify and resolve bottlenecks and improve efficiency, ensuring that the software delivery process adheres to industry best practices and regulatory requirements. So now that you understand the roles and responsibilities of a DevOps professional, let's take a look at the roadmap to become a DevOps professional. So first is to learn the basics of software development. To be an effective DevOps professional, it's essential to have a good understanding of software development processes, including programming languages, software development methodologies, and version control tools. You can start by learning programming languages like Python, Java, or Ruby. Well, a DevOps Engineer course will prepare you for a career in DevOps technologies. Through this DevOps Engineer course, you will learn to review deployment methodologies, CI/CD pipelines, observability, and use DevOps tools like Git, Docker, and Jenkins with this DevOps Engineer Certification. You can check out the link for this course in the description. Following that, learn about infrastructure and operations as a DevOps professional. You will be responsible for managing infrastructure, including servers, databases, and network system. So it's essential to have a good understanding of infrastructure and operations. This includes learning about servers, operating systems, network protocols, and storage systems. Then explore about automation tools and cloud services. Automation is a critical part of DevOps. Learning automation tools such as Ansible, Puppet, or Chef can help you streamline the software delivery process and improve efficiency. Most organizations today use cloud services to deliver software. Learning cloud services such as AWS, Azure, or GCP can help you design and implement cloud architecture that are efficient and scalable. Well, to help you with learning DevOps and cloud services, Simplilearn has to offer Azure DevOps Solution Expert Master's Program to help you become an industry-ready professional. In this course, you will learn to plan smarter, collaborate better, and ship faster with a set of modern development services. The link for this course is mentioned in the description. Do check them out. Once done with skilling, you need to gain experience and get certified as discussed before. The best way to gain experience in DevOps is to work on real-world projects. This can be achieved through internships, volunteering for open source projects, or even taking on small projects on your own. This will allow you to put your theoretical knowledge into practice and gain hands-on experience. Along with it, there are various certification programs available, such as the DevOps Institute Certification Program, AWS Certification DevOps Engineer, and Microsoft Azure DevOps Solutions Certification. Once you have gained experience and acquired the necessary skills, it's time to start looking for job opportunities. There are various job titles in DevOps, such as DevOps Engineer, Site Reliability Engineer, Automation Engineer, and Release Engineer. In top hiring companies in the field include Amazon, Google, Microsoft, IBM, and
In this video on DevOps Engineering Roadmap 2024, we will be covering what is DevOps, DevOps Engineering Roadmap, responsibilities of DevOps Engineer, salary, and companies hiring. Let me ask you a quick question. So, which of the following is a key objective of DevOps? Option A is slowing down software development. Option B is increasing the gap between development and operations. Option C is automating and streamlining software delivery. Option D is reducing collaboration among teams. Now you can pause this video and answer in the comment section below. Alright, so now let's start with the first topic, which is what is DevOps? So DevOps is a collaborative approach that brings together software development, that is dev, and IT operations, that is ops teams, to streamline the software delivery process. It emphasizes communication, collaboration, automation to enable faster and more reliable software releases. DevOps aims to break down the wall between teams, allowing for seamless integration and continuous feedback throughout the development lifecycle. By automating tasks such as code testing, deployment, and infrastructure management, DevOps promotes and stability. Ultimately, DevOps fosters a culture of collaboration, innovation, and continuous improvement, enabling organizations to deliver high-quality software at faster pace to meet customer demand. Alright, now let's move on and understand the DevOps engineering roadmap. So, the DevOps engineers need to possess a diverse set of skills. So, let's explore the importance of key skills in the DevOps engineer roadmap. First we have is Linux. Linux is an open source operating system widely used in the DevOps world. DevOps engineers need to be familiar with Linux as it is commonly used for server management, scripting, and automation. Understanding Linux commands and system administrations helps in effectively managing infrastructure. Next skill is Jenkins CI/CD. Continuous integration and continuous delivery deployment, that is CI/CD, are essential practices in DevOps. Jenkins is a popular tool for automating the CI/CD pipeline, allowing for frequent code integration, testing, and deployment. DevOps engineers need to understand Jenkins to enable faster and more reliable software releases. The next skill that you must possess in order to become a DevOps engineer is Docker and Docker Swarm. Containerization with Docker allows for consistent and portable application deployments. DevOps engineers use Dockers to package applications and their dependencies into containers, making them easier to manage and deploy. Docker Swarm helps in orchestration and scaling containerization applications, ensuring high availability and efficient resource utilization. Coming to the next one, which is Kubernetes. Kubernetes is crucial for managing containerization application at a scale. It automates the deployment, scaling, and management of containers, making it easier to manage complex environments. DevOps engineers need to understand Kubernetes to ensure efficient resource allocations, high availability, and seamless application scaling. Alright, now moving on to the next skill, which is cloud platforms. So cloud platforms provide on-demand resources and services, enabling scalability and flexibility. DevOps engineers need to be proficient in cloud platforms like AWS, Azure, or Google Cloud to deploy and manage applications in the cloud. This allows for efficient resource provisioning, scalability, and cost optimization. Next up we have is version control system. So version control systems like Git are essential for collaboration and managing code changes. DevOps engineers use version control systems to track changes, collaborate with team members, and ensure code integrity. It enables efficient code management, versioning, and collaboration across teams. Following this, there is monitoring and logging. Monitoring and logging tools are crucial for tracking applications and infrastructure performance. DevOps engineers set up monitoring systems to proactively identify issues troubleshoot problems, and ensure optimal performance and availability. Logging helps in capturing and analyzing applications, logs for debugging and performance optimization. Each of these skills plays a vital role in enabling collaboration, automation, scalability, and reliability in the DevOps workflow. They help DevOps engineers streamline process, improve efficiency, and deliver high-quality software at a faster pace. Now, let's talk about the responsibilities of a DevOps engineer. So as a DevOps engineer, your responsibilities revolve around bridging the gap between development and operation teams to ensure smooth and efficient software delivery. Here are some key responsibilities explained in the understandable manner. First is collaboration. Here collaboration means you work closely with development, operations, and other cross-functional teams to foster collaborations and streamline communication. And performance. Here monitor and performance means you set up monitoring systems to track the performance and health of applications and infrastructure. This helps in identifying and resolving issues proactively. Then third is release management. In this, you manage the release process, coordinating with different teams to plan and execute software releases. Alright. Next is continuous integration and deployment. In this, you automate the process of integration code changes from developers and deploying them to the production environments. Next is troubleshooting and support. In troubleshooting and support, you investigate and resolve issues related to application or infrastructure performance, working closely with development and operation teams. Then there is continuous improvement. In continuous improvement, you continuously evaluate and improve existing processes, tools, and infrastructure to enhance efficiency and scalability. Right? Then there is security and compliance. In this, you implement security measures and best practices to protect applications and infrastructure from potential threats. Alright, so this was about the responsibilities of a DevOps engineer. Now let's talk about the interesting part, which is the salary. Alright, so on an average, a DevOps engineer in the United States can expect to earn between $138,000 per positions may start around $70,000 to $90,000 per year. It's important to note that these figures are approximate and can vary significantly based on individual circumstances. Alright, so this was the salary. Now let's talk about the companies hiring for DevOps engineer. So first of all, there is Mercedes-Benz Research and Development, India. A company based in Bengaluru, India that requires DevOps engineers with skills in AWS, Kubernetes, Docker, Jenkins and Python. The next big company is IBM, a multinational company that has openings for DevOps engineer. Then there is Flipkart. Flipkart, a leading e-commerce company that is looking for DevOps engineers with expertise in Linux, Git, Terraform, and monitoring tools. Next company is CoreOver, a remote company that offers full-time positions for DevOps engineers with experience in integrations, updates, fixes, and technical support. Then there is Accenture. Accenture is currently seeking DevOps engineers to optimize their IT operations and software development processes. Then Oracle. Oracle is actively recruiting DevOps engineers to enhance their IT operations and streamline software development. At last we have is SAP. SAP is looking for DevOps engineers to improve their IT operations and software development practices. As you follow this DevOps roadmap, keep in mind that it's not just a path but an ongoing journey. Embrace the idea of always learning things easier with automation. As you hit each milestone, you will not only make things run smoother, but also create a culture of teamwork and improvement in your workplace. What is DevOps? DevOps is like a teamwork approach for making computer programs better and faster. It combines the work of software developers and the operation team. The goal is to help them work together and use tools that speed up the process and make fewer mistakes. They also keep an eye on the programs and fix problems early. This way, businesses can release programs faster with few errors and everyone works better together. If you want to learn more about this, then check postgraduate program in DevOps to understand from the basics to advanced concepts. This postgraduate program in DevOps is crafted in partnership with Caltech CTME. This comprehensive course aligns your expertise with industry benchmarks. Experience our innovative blended learning, merging live online DevOps certification sessions with immersive labs for practical mastery. Advance your career with hands-on training that meets industry demands. Alright, now let's move on to the first question of DevOps interview question, which is, what do you know about DevOps? So think of a DevOps like teamwork in the IT world. It's become really important because it helps teams work together smoothly to make computer programs faster and with fewer mistakes. Imagine a soccer team, everyone works together to win the game. DevOps is similar. It's when computer developers and operations people team up to make software better. They start working together from the beginning, when they plan what the software will be like, until they finish and put it out for people to use. This teamwork makes sure things go well and the software works great. So this was about DevOps. Now moving on to the second question, which is how is DevOps different from Agile methodology? DevOps is like a teamwork culture where the people who create the software and the people who make it work smoothly join forces. This helps in always improving and updating the software without any big breaks. Agile is a way of making softwares that's like taking small steps towards instead of big jumps. It's about releasing small parts of the software quickly and getting feedback from the users. This helps in solving any issues or differences between what users want and what developers are making. So you can answer this question in this way. Alright, moving on to the third question, which is what are the ways in which a build can be scheduled/run in Jenkins? So as you can see, there are 4 ways: by source code management commits, second is after the completion of other builds, third is scheduled to run at a specified time, and fourth one is manual build requests. So if the interviewer asks, then you can answer these 4 ways in which a build can be scheduled in Jenkins. Alright, now the fourth question is what are the different phases in DevOps? So the various phases of DevOps lifecycle are as follows. So as you can see, first is plan. So initially there should be a plan for the type of application that needs to be developed. Getting a rough picture of the development process is always a good idea. Then code. The application is coded as per the end user requirements. Then there is build. Build the application by integrating various codes formed in previous steps. After that there is test. This is the most crucial step of the application development. Test the application and rebuild if necessary. Then there is integrate. So multiple codes from different programmers are integrated into one. After integrate there is deploy. So code is deployed into a cloud environment for further usage. It is ensured that any new changes do not affect the functioning of a high traffic website. After that there is operate. So operations are performed on the code if required. Then there is monitor. Application's performance is monitored. Changes are made to meet the end user requirements. So these all were the different phases of DevOps. And here we have explained each one of these. You can go through it, and if the interviewer have asked you this question, you can answer it in a similar way. Alright, now moving on to the next question, which is mention some of the core benefits of DevOps. So the core benefits of DevOps are as follows. First of all, we'll say technical benefits. First, technical benefit of DevOps is continuous software delivery. Then second is less complex problems to manage. Third is early detection and faster correction of defects. Then here comes the business benefits. The first benefit of DevOps, that is business benefit of DevOps, is faster delivery of features. So it allows faster delivery of features. Then there is stable operation environment. Then third one is improved communication and collaboration between the teams. So these were the business benefits. So here we have discussed both technical benefits and business benefits. Alright, now the next question is how will you approach a project that needs to implement DevOps? So here are the simpler terms. Here's how we can bring DevOps into a specific project using these steps. Step 1 would be first, we look at how things are currently done and figure out where we can make them better. This makes about 2 to 3 weeks. Then we can plan for what changes to make. Then step 2 would be we create a small test to show that our plan works. When everyone agrees with it, we can start making the real changes and put the plan into action. Then third step would be we are all set to actually use DevOps. We do things like keeping track of different versions of our work, putting everything together, testing it, and making it available to the users. We also watch how it's working to make sure everything goes smoothly. By doing these steps right, the keeping track of changes, putting everything together, testing, and watching how it's going, we are all set to use DevOps in our project. So this is how you can approach a project that needs to implement in DevOps. And this is how you can answer this question. Alright, moving on to the question number 7, which is what is the difference between continuous delivery and continuous deployment? Alright, so first would be continuous delivery. So it ensures code can be safely deployed on production, whereas continuous deployment, here every change that passes the automated test is deployed to production automatically. Then in continuous delivery, it ensures business applications and services functions as expected, whereas in continuous deployment, it makes software development and the release process faster and more robust. In continuous delivery, delivers every change to a production-like environment through rigorous and automated testing. Whereas in continuous deployment, there is no explicit approval from a developer and requires a developed culture of monitoring. So these were the 3 points that you can highlight while differentiating between continuous delivery and continuous deployment. Alright. So this was the question number 7. Now moving on to the question number 8, which is name 3 security mechanisms of Jenkins uses to authenticate users. So here we have to name 3 security mechanisms. First one would be Jenkins uses an internal database to store user data and credentials. Second is Jenkins can use the lightweight directory access protocol, that is LDAP server, to authenticate users. Third one is Jenkins can be configured to employ the authentication mechanism that the deployed application server uses. So these were the 3 mechanisms that Jenkins uses to authenticate users. Alright, now moving on to the question number 9, which is how does continuous monitoring help you maintain the entire architecture of the system? So continuous monitoring within DevOps involves the ongoing identification, detection, and reporting of any anomalies or security risk across the entire system infrastructure. It guarantees the proper functioning of services, applications, and resources on servers. By overseeing server statuses, it accesses the accuracy of application operations. This practice also facilitates uninterrupted audits, transaction scrutiny, and regulated surveillance. So this was about the question number 9, that was how does continuous monitoring help you maintain the entire architecture of the system. Now moving on to the question number 10, which is what is the role of AWS in DevOps? So in the realm of DevOps, AWS assumes several roles. First one would be adaptable services. So it offers adaptable pre-configured services, eliminating the necessity for software installation or configuration. Second one is designed for expansion. Whether managing one instance or expanding to 1,000, AWS services accommodate seamless scalability. Then there is automated operations. AWS empowers task and process automation, freeing up valuable time for inventive pursuits. The next one is enhanced security. AWS Identity and Access Management, that is IAM, allows precise user permissions and policy establishment. Then the last one is extensive partner network. So AWS fosters a vast partner network that integrates with and enhances its service offerings. So these were the role of AWS in the realm of DevOps. Alright, now moving on to the question number 11. Name 3 important DevOps KPIs. The 3 important KPIs are as follows. First one is mean time to failure recovery. This is the average time taken to recover from a failure. Second KPI is deployment frequency. The frequency in which the deployment occurs is called deployment frequency. Third one is percentage of failed deployments. The number of times the deployment fails is called percentage of failed deployments. So these were the 3 important DevOps KPIs. This question can also be asked. Alright, moving on to question number 12, which is how is IAC implemented using AWS? So commence by discussing traditional methods involving scripting commands into files, followed by testing in isolated environments prior to deployment. Notice how this practice is giving way to infrastructure as code IAC. Comparable to code for various services, IAC aided by AWS empowers developers to craft, accesses, and manage infrastructure components descriptively utilizing formats like JSON or YAML. This fosters streamlined development and expeditious implementation of alterations in infrastructure. Alright, now moving on to question number 13, which is describe the branching strategies you have used. They'll ask you this question. So to test our knowledge, the purpose of branching and our experience of branching at a past job, this question is usually asked. So here we will discuss topics that can help you answering this DevOps interview question. So release branching. we can clone the develop branch to create a release branch once it has enough functionality for a release. This branch kicks off the next release cycle, thus no new features can be contributed beyond this point. The things that can be contributed are documentation generation, bug fixing, and other release related tasks. The release is merged into master and given a version number once it is ready to ship. It should also be merged back into the development branch, which may have evolved since the initial release. So this was the first one. Then there is feature branching. This branching model maintains all modifications for a specific feature contained within a branch. The branch gets merged into master once the feature has been completely tested and approved by using tests that are automated. Then the third branching is task branching. In this branching model, every task is implemented in its respective branch. The task key is mentioned in the branch name. We need to simply look at the task key in the branch name to discover which code implements which tasks. So these were the branching strategies that you can say that you have used, or if you have really used it, otherwise you can say something else. Alright, moving on to question number 14, which is, can you explain the shift left to reduce failure concept in DevOps? So shifting left within the DevOps framework is a concept aimed to enhance security, performance, and related aspects. To illustrate, consider the entity of DevOps processes. Currently, security evaluations occur before the deployment stage. By employing the left shift approach, we can introduce security measures during the earlier development phase, denoted as the left. This integration spans some multiple phases, encompassing pre-development and testing, not confined to development alone. This holistic integration is likely to elevate security measures by identifying vulnerabilities at initial stage, leading to a more fortified overall process. Now moving on to the question number 15, which is, what is blue/green deployment pattern? So this approach involves seamless deployment aimed at minimizing downtime. It entails shifting traffic from one instance to another, requiring the replacement of outdated code and a new version to integrate fresh code. The updated version resides in a green environment, while the older one remains in a blue environment. After modifying the existing version, a new instance is generated from the old one to execute the updated instance, ensuring a smoother transition. So the main focus of this approach is smooth deployment. Alright, so this was question number 15. Now moving on to the question number 16, which is, what is continuous testing? So continuous testing involves the automated execution of tests within the software delivery pipeline, offering immediate insights into potential business risks within the latest release. By seamlessly integrating testing into every stage of the software delivery lifecycle, by seamlessly integrating testing into every stage of software delivery lifecycle, continuous testing minimizes issues during transition phases and empowers development teams and instant feedback. This approach accelerates developer efficiency by obtaining the need to rerun all tests after each update and project rebuild, culminating in notable gains in speed and productivity. So this was about continuous testing. Now moving on to question number 17. What are the benefits of automation testing? So some of the benefits of automation testing includes, first, it helps to save money and time. Second is, unattended execution can be easily done. Third one is, huge test matrices can be easily tested. The next one is, parallel execution is enabled. Then there is reduced human generated errors, which results in improved accuracy. And last one is, repeated test tasks execution is supported. So these are the benefits of automation testing. Coming to question number 18, which is, what is a Docker file used for? So a Docker file is used for creating Docker images using the build command. With a Docker image, any user can run the code to create Docker containers. Once Docker image is built, it's uploaded in Docker registry. From the Docker registry, users can get the Docker image and build new containers whenever they want. So this is what Docker file is used for. Coming to question number 19, which is, what is the process for reverting a commit that has already been pushed and made public? So there are two ways to do that, to revert a commit. So first would be remove or fix the bad file in a new commit and push it to the remote repository. Then commit it to the remote repository using git commit -m commit message. Again, git commit -m commit message. So this is the first way. Then second is create a new commit that undoes all the changes that were made in the bad commit. Then use the command git revert commit id. As you can see in the screen, first command also and the second command also. The second command says git revert commit id. Commit id, you will have to put the commit id. Alright, so question number 19 this was. Now moving on to the last question, which is question number 20. How do you find a list of files that have been changed in a particular commit? So the answer would be, the command to get a list of files that have been changed in a particular commit is git diff tree -r. Then there is commit hash. So this command, as you can see on the screen, git diff tree -r commit hash, you can put it. Then example is also there, like commit hash 87E6735F21B. So this is example, as you can see on the screen. Then there is -r flag instruct, so the command to list individual files, and commit hash will list all the files that were changed to or added in that commit. So there's telling about the, as you can see, -r functionality. -r is a flag that instructs the command to list individual files, and commit hash will list all the files that were changed or added in that commit. So these were the top 20 DevOps interview questions that you must understand if you're planning to give a DevOps interview. So in this video, we have explored key concepts, methodologies, and best practices that are crucial in fostering collaboration between development and operations teams. By understanding the principles discussed here, you are well equipped to navigate the dynamic landscape of DevOps and drive successful software delivery. That's it for our DevOps Fundamentals for Beginners in 2023 video. We have covered essential concepts like Agile versus DevOps, CI/CD, Git and GitHub, Selenium, Docker, and Kubernetes in a beginner-friendly way. We hope you feel more confident about how DevOps can improve software development. Remember, practice makes perfect, so keep exploring and experimenting with these concepts. If you have any questions or topics you would like us to cover in future videos, please leave them in the comment section below. Thanks for watching, and we will see you in the next one.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.